Hello and welcome back to another coding session with Mr. Jacob. Today we want to make our sand simulation a little bit more sandy, color-wise and maybe movement-wise, and yeah, we will actually see what we can do. And we still have some bugs to fix here, so maybe we will do that as well. We will see. So let's start by introducing a little bit more randomness into this. Because first of all, I want more randomness when we are having the sand falling here. Like I want to make the speed maybe a little bit random and the start point of the particles a little bit random. And from most and foremost, I want to make the color a little bit more random because that doesn't look really nice. So what we need is some more randomness. So let's introduce that. And I guess we will need to introduce that into our pixel loop system or engine, or I'm still not sure what to call that. It's not really an engine. It's just a very small wrapper around some libraries. But yeah, why not? Why not call it an engine? I guess we need to introduce that somehow so that we can actually provide it to our update and render functions, or even maybe our event handling functions. We will see. And I guess we will provide more of those stuff in the future. Like we might want to provide some sort of asset management to the functions, or we might want to provide some sort of input handling and management to the functions. And I guess I don't want to do all that using the game state, so because then I would need to implement it all over again, all of the time. So maybe we will introduce something like an engine state or something like that. Yeah, we will see. First of all, let's see what kind of randomness we can use. What was it? Rand. There was something like a rand book for Rust, and there was an overview of all the different generators, because I guess we don't necessarily want a cryptographically safe random generator. We more or less want a fast one. So where was it? Different rand generators, Rust. There it is. It is in the Rust rand book. Yeah, I simply didn't know where to click. Okay, so exactly, this was an overview of the pseudo-random number generators, which are a lot faster than, if we can see here, the cryptographically secure ones, which actually, and that is the case, the STD RNG generator that we get by default from Rust is actually quite slow. But yeah, it's cryptographically secure, so I guess it makes sense to do that. So what do we have here? We have different ones. We have different ones with different speeds and qualities. And let's see, we have 7. Okay, not portable. That doesn't sound so good. So 7, 7, 3, 4, 7, 8. Yeah, but that one isn't very. What does 2 stars mean? No major issues in qualitative testing. Okay. Yeah, but maybe we could use this one. No idea. What's with this one? It seems reasonably fast, and it seems reasonably good. Yeah, why not? So let's see. Let's take this one. Where is it actually defined? Rand. Can we? That's actually a crate. So. Oh, and it has all of those. I see, it has all of those implementations there. Yeah, but I think I want this one then. So let's maybe install it, cargo add. I guess we can easily replace it with something else in the future, should we want to. So because I intend to actually put an interface before it anyways, because I guess we need some sort of other randomization than simply numbers or whatever this can provide. We will see in a second what it can give us actually. So yeah, first of all then let's introduce something like, let's introduce an engine state. Yeah, I guess we call it engine state for now until I know a better name for it. If you have any recommendations or ideas about the name, please leave me a comment or contact me. Okay, so this engine state will have something like random, I guess. And let's call that random generator. I mean, there is a quite, does this implement, what was it? It was this one. Does this one implement this rand interface? Because RNG core, is RNG core actually the one with all the different, so next U32, next U64, fill bytes, try fill bytes. Okay, that's it. Okay. So RNG core is really a very minimal implementation. Okay. So, but there was something like Rust, RNG. What was the interface called that that most of the trait called that most of them? So a marker trait used to indicate that an RNG core or block RNG core implementation is supposed to be cryptographically RNG, an automatically implemented extension trait on RNG core providing high-level generic methods for sampling values other than convenience methods. Okay, is this the one I was searching for? So gen, yeah, exactly. Gen range, sample, and so on and so on. Fill. So this one actually can give us all the different kinds of things we want, and this one is automatically implemented extension trait on RNG core providing high-level generic methods for sampling values and other convenience methods. Where actually does it come from? It's part of the rand crate, so we need to install rand as well? Yeah, I kind of guess so. So cargo add rand. And can we maybe disable some stuff here? STD, RNG, do we even need that then? Because that is actually rand chacha, I have no idea. Yeah, maybe we could disable something there, but let's see. So maybe random, or let's then call it rand, is simply an implementation of that RNG trait. That would actually, I think that would actually quite nice. So can I do that? Or let's call it rand RNG. I guess I need to box it or something like that. So I don't need that import. I guess I will need to box it. Yeah. Wait, what? Wait, what? An automatically implemented extension providing and so on and so on. No, I want to see the error. Wait, I don't want there. Cannot be made into an object. Yeah, what's the... Needs to be building a V-table to allow the call to be resolved dynamically for more information and so on and so on and so on. So cannot be made into an object because method gen has generic type parameters. Yeah, okay, but can we then do something like RNG? Can we do that so that it can be decided at compile time what to put in there? So yeah, this needs to be rand RNG. Okay. Yeah, okay, I think this is fine then. So let's give this engine state for now something like a default impl. Engine state. Yeah, and interesting. So if we put a specific, no, actually this should be fine. So let's do that here, rand RNG, and let's implement. It doesn't want that. Impl default for, okay, maybe it doesn't like that. Where R is rand RNG. Does this work then? Oh, I'm missing a 4. That's what it complained, or why it was complaining. I see. Okay, so as a random, I guess we will then put in there for now this, what was it called? Rand Soshiro something plus plus. Yeah, this one. So how do we actually initialize this one? Okay, so we seed it from a U64. So could we use, isn't an instant a U64? Let's see. Let now equals instant now. What actually do we get back here? We get an instant back. But what is an instant specifically? Let's see. Instant. What is that? It's a struct with a time instant in it, and that's a time spec, and holy shit. And there is an tvsec. Yeah, that's actually kind of what I want. Can't I just extract the, is there a method to get this thing here from it? Like, instant. Oh, did I delete I did delete it. So now, returns an instant. Is there any implementation on instant? Let's check that. Docs rs instant. So can I somewhat instant? No, I don't want. It's std time instant rust, isn't it? Instant. So does it have some, it's a little bit too big for me to read. So what does it have? Implementation. Now, yeah. It returns an instant. I get that. So what actually do we have here? Check duration since, etc. and so on and so on. Elapsed, checked sub. Okay, trait implementations. It has add, assign, clone. Doesn't it implement something like, can't we, I want it as a two, no, what? Wait, I didn't, what was that? Can I somewhat convert it to a number or something like that? Now elapsed as sex. So what is elapsed? Returns the amount of time elapsed from another instant to this one, or none if that instance is later. Yeah. Okay, this returns a duration, but can't I do something like as only a duration can be as sex or something like that? Duration since returns the amount of time elapsed from another instance to this one, or 0. Checked add, saturation, duration, add, clone, copy, debug, partial, sub, freeze something, blanket implementations. Into what can we actually, we can't see that here. In std time. Constants, Unix epoch, an anchor in which create the system time instances or learn where, wait, what? Oh, okay. Yeah, that would be actually something that we could do. Yeah, I guess that is something that we could do then. Okay, let's do it like this. Let's get the, okay, so system time, now duration since, unique epoch, dot unwrap. So we assume that this is fine. So, and then we want as, can we do something like, wait, it doesn't know that, does it? std, yeah, let's maybe import that, I guess. And let's maybe import that, I guess. And then, let's see, can we do something like as micros? So we maybe could. The question is, let micros. The question is, that's a U128. So it's maybe even a little bit too much. However, why actually not, I guess? So can we get it as millis maybe? That should be a U64 then? Still a U128. So let's get it as micros. And then let's just, why not? We can just throw away 64 bits of it. So we can just do something like micros as U64. So we are just throwing away information there. But that's not that hard because we want that part still. So I guess we need to import that one. And then this one, no function or social. Wait, what? Didn't I import seedable RNG? So, okay. Expected type parameter R found. Yeah, but this one should actually implement that, shouldn't it? I assumed it would. Doesn't this struct implement this, wait, seedable RNG core? And wasn't there the talking that the RNG thingy is automatically implemented? Wait. Trait. Automatically implemented extension trait on RNG core, providing high-level generic methods for sampling values and other, yeah. Okay, so the basic pattern is every RNG core implements RNG. Let me make this a little bit bigger. It makes no difference whether we use R RNG or R RNG core. The sized unbounding always functions to be called directly on type erased references. Okay. Without that, it would be necessary to write foo R. So maybe we need something like that. Let's see. Plus sized, maybe, and then here as well, plus sized. I don't really understand the size for value of type R cannot be known at compilation time. Doesn't have full size known at compile time. This type parameter needs to be sized. Yeah. Wait, what? Okay, maybe let's make I think I'm not seeing something very trivial here regarding traits, which I don't know. So make a generic over RNG trait. So let's for now cut this out here and let's simply say this is a something. I can't pronounce it. So let's remove that just to get going. We have already used way too much time on this. So now we should be able to create something called engine state. And I guess I want that as part of our engine state. And let's introduce it here. And I guess when we are creating this thing, we want to create an engine state default. There we go. And now we should actually have that available. So we should introduce that to our render functions. So I guess it will be the first thing we introduce. And the question is, does it need to be mutable? I guess it does, because I guess the random generator, for example, is something that is actually a mutable thing. So let's introduce a mutable reference to engine state here. And, oh, no, the type, of course. Engine state, and maybe introduce a mutable reference here to engine state. Yeah, and I guess I could even provide it here. Why not? We might need that in the future. Mute engine state. So now we will have a lot of compile errors, I guess. Yeah. So what we need to do here now is we need to put in a mute self engine state. Let's go to the next one. Mute self engine state. And the next one, yes, mute, pixel loop engine state, because this is outside of there. So now I guess we will type engine state is more private than the, yeah, engine state, come on, there it is. It needs to be public now, of course, and yeah. So now let's see. Yeah, this one doesn't work anymore, so it takes an engine state, I guess. And this one takes an engine state as well. So where was the next problem? There. This takes an engine state as well. Okay. And now we are having an unused import here. Okay, let's remove that. Okay, so let's see if this actually still compiles and works. It needs to compile rand, yeah, okay. Okay, so now we actually have something random there. So let's maybe start by randomizing the color a little, I guess. So where's our, no, we need to go here. Where is actually our color? Where do we draw that color thingy here? Update particles, no, there, that's the interesting thing. So what we're actually putting in here is a default send particle, and the default send particle has, interesting. Maybe we should introduce the capability to put some color directly into the send. So where is our send? Where is our struct send? There it is. So let's see, let's maybe not implement default here, but let's implement send, and then we can call this new, and then actually we can move it into this other implementation block, even though Rust doesn't complain if you have multiple implementation blocks for the same struct. You can actually have that. So I could have actually another one here called impl send something, and it would be perfectly all right. Yeah, but now I guess I want something like base color here. Yeah, I guess I will take something like base color. And we call this one now base color, not color. Or maybe, no, maybe we call it color. We can still call it color because we are creating this color from the base color. Okay, let's see. Let's do something like let color equals. And now we need, how would we vary the color? So, something like create sand color variation, and we put in the base color there, and I guess we need to implement it in a way that we get out, maybe let's just call it sand color variation. Okay, so let's maybe implement that quickly. How would that actually look like? Fn send color variation. So we need to call that on self. Okay, so send color variation takes a color in, takes a reference to a color in. So color is a reference to color and it outputs another color. And yeah, let's see. So we need to reference that then there. And actually we could take this as a reference. Yeah, let's take it as a reference. I don't think it's a problem because we are not keeping it. So why should we take ownership of that? Doesn't make sense. So how would we do that? I guess we would need to vary the brightness of it, just the brightness, not the hue, maybe the brightness and the saturation, something like that. So we are keeping the hue, the color, but we are varying a little brightness and saturation. Yeah, that would actually kind of make sense. I guess. Yeah, so I guess we need something like HSL to, no, RGB to HSL, and then the other way around. Yes, something like that. No, I want the algorithm. So yeah, something like that, exactly. Posted a JavaScript solution, his blog, and so on and so on. Yeah, we kind of need something like that, and then we can actually implement that HSL to RGB. And here is something like hue to RGB, and then yeah, okay, and then we need RGB to HSL. Yeah, perfect. Wait, HSL to RGB. Yeah, we need this one. Yeah. So let's. Where is the share? Copy link address. Yeah. So let's first of all put that in there, and let's create, I guess, in our color thingy, some color struct. Yeah, we need some stuff here. So what we want actually is something like as or into. Does it consume it? Yeah, I guess as is okay. As HSL. So fn, I'm not sure how we are actually going to represent that, because that is kind of something different. Maybe for now we are representing that with floating, just with a tuple of floating points. Or maybe we should just introduce something like an HSL. We should introduce maybe a struct HSL color, and that one actually can hold H, which is an F64, S, so saturation, which is an F64, so hue, saturation, and lightness, I guess it's called. So the amount of brightness in the color. And then we want something like impl HSL color. And then we will do something like new H. So this is a function F64S, F64L, F64, and this one returns self. So it's quite easy in HSL. Okay, so, and I guess we will implement then based on that in the future. So this now returns an HSL color. Yeah, so let's see. Okay, so now we can guess, I think, taken and converted from. There we go. That was what I wanted to do. And now where are we? There we are. So let's take this code here and let's put it in there and let's see what we can do with that. So actually this one is first of all converting things into the 1 to 0 space. Okay, we can do that. So let R equal, we need to take a self here. So R is self.R divided by 255, self.R as F64 divided by 255. Yeah, okay. And we need the same things for G and B. So G and B. Okay, so what is it doing here now? It's calculating the max and minimal values of those three. Okay, perfect. We can do that. Let Vmax be equal R max R B max no G, come on, G max B. So this should the maximum of them of those three. Yeah, okay. Then the minimum as well. So min, not nin, min. Okay, next one. So now we say that, okay, H, can I actually do something like that in Rust? No idea? No. That would have been kind of strange, I guess. So let H equal, can I do something like that? No. Okay, so H is Vmax plus Vmin, so the maximum and the minimum divided by 2. Okay. So I guess we are doing that for all of those first off, and then, okay, so if Vmax equals Vmin, we are returning H as our color, new 0, 0, L. Okay. Otherwise, we are doing some further math. So I guess we need to change all of those. So they are all mutable. So let's see. D is Vmax minus Vmin. Okay. Holy shit! What a crappy way of writing this. If so, S equals if L is bigger than 0.5, 0.5, then we want D divided by 2 minus V, 2.0 minus V max, max minus V min. Otherwise, we want D divided by V max plus V min. Okay. Guess we can do that. And then if V max equals R, so is this the already, yeah, it's the already transformed R. I see. So then we want the hue to be G minus B, so divided by D. And then if G is smaller than B, we actually want to make H plus equal 6. Otherwise, we don't. 6.0. And that's that. So if Vmax equals G, then H equals B minus R divided by D plus 2. Plus 2.0. Okay, so, and then we are dividing by 6. Okay, I don't. Yeah, then let it be, I guess. So if Vmax equals B, then H equals R minus G divided by D plus 4.0. There we go. And then we are actually dividing H by 6, and then we are returning a new HSL color, new HSL, yes. So, and I guess I can remove those braces here. And yeah, why actually? Okay, L is not mutated at all. And S, what is the problem with S? Assigned but never read? Wait, what? I'm definitely reading from it here. Oh, it is assigned. Yeah, exactly. It is assigned here, but it is then directly overwritten here. So yeah, maybe we don't need it there and we can actually do that. Because then we are only, so we are first calculating lightness. So this is actually here the lightness that we calculate. And the basic hue, I'm not sure for what we are using that. Aren't we overriding that directly? No, we are using it actually to, no, we aren't reading that as well, are we? So we are calculating, that's the distance. So we are calculating the saturation here then based on the lightness and the distance. And then we are setting actually possibly the H here. Otherwise we are setting the H here or the H here. So actually we are definitely setting the H. So I'm not sure why we are initializing the H here with this value. This isn't even needed really. So I guess we could do something like, could remove that, and I guess that would be more to my liking. Is we could do something like let H equal, and then there comes this one, or this one, or this one. Wait, are we actually overriding those things? So if Vmax is R, then we are calculating it this way. And then the same thing, if Vmax is G as well, then we are using this one. And that doesn't make sense in my opinion. So, okay. But we are overriding it really. So I guess it doesn't really make any difference there. But yeah, I don't really know. So let's do something like that. Okay, and then, yeah, possibly uninitialized. Yeah, because, oh, I see. Okay, accepted. If none of those values actually is the maximum there, then we will use that value. Okay, and simply divide it by 6. Okay, accepted. Okay, so now we should be able to convert into HSL color. Where is our send thingy here? Send. Send there. So now we actually can't do that anymore. We need to provide a base color. Yeah, let's provide for now color from RGB. Let's for now just provide the base color yellow there. And yeah, now we have this exactly. That was where we stopped. So what we actually want to do here is we want something like HSL equal color dot as HSL. So function HSL is private? Oh, is it? As HSL. As HSL. There. No, it's not private, but I guess HSL color is private, is it? So yeah, so let's make this one public, pub. And I guess the new function should be public as well. Okay, so now we can actually create an HSL color. So now let's see. Let's do something like, we want to keep the hue, but we want to manipulate saturation and lightness based on random. So we somehow need to put a random thingy in here. Can we do something like, can I do this now? Let's see. Let's do rand RNG. So can I put this in there now and say rand and say it's an R? It's a mutable reference to an R. So maybe this is where I need this one sized. Let's see. Maybe this works. So oh, I guess that means that for creating a new send, yeah, but why not? Then we need that. So RNG rand RNG plus sized, and I guess then we are just putting a mutable reference to an R in here as well. And then we can pass that to, oh, I need the angle bracket there, and then we can pass that on to the send color variation thingy here. Okay, so now we should be able to do something like, let saturation equal rand dot. Can't I, the rand thingy, can it generate? I guess it can, a floating point, a simple float, something like gen. Returns a random value supporting the standard distribution. Yeah, nice. But it can definitely do different types. Yeah, okay, so I see. Arrays and tuples, but can it do that in a range? Gen range, nice. So, oh, wait. So the problem is if I let it generate a Unicode value, is it a Unicode value between 0 and 1? I would hope so. I don't know. Yeah, but I would assume it, because Unicode, everything else doesn't really Unicode, floating point. What the hell? Wouldn't make any sense. So let's use an F64 here, and let's see. What I actually want is I want some delta S, and I want actually something between, let's say, no idea, -10 and 10, for example. So 255 by 10. I don't know, 255. What am I even calculating here? Yeah. So let's do something like 25 times the value minus 25 divided by 2, so that we are actually having plus and minus in this range. Yeah, something like that. And I want the same thing for the the lightness, and then I want to create a new color, and I call it from HSL, and I guess then I would need to do something like HSL color new yeah, HSL hue, HSL. Oh, I can't access those, can I? They are not public. Yeah, we can make them public. Saturation plus the delta of the saturation, and HSL lightness plus the delta of the lightness. Something like that, I guess. So let's change some things here. So first of all, we need to import the HSL color, and then we we need to, what the hell? Then we need to make those one public, I guess. Yeah. And then let's see. So now this should actually be creatable. Function new is private. Yeah, that's bad. So let's make it public. I don't see a reason why it shouldn't be. So actually, we are never really in. That's interesting. That's interesting. Yeah, so okay, so yeah, let's make them public for now. Why not? Okay, so but now we need a function here which can do something like no, what we actually want is what we want is something like that. We want something like that, and then we want into, and we want actually implement on HSL color. Either I guess we want to implement a from on color for the HSL color. So let's see. So I guess we want impl from HSL color, or better said, from a reference to HSL color for color. So now actually I should be able to do something like use the algorithm that we had here, the other one. Where is it? There, that one. Yeah. Okay. So okay. So yeah, maybe take that, and then I will mention that here as well. So let me copy that. Wait, where was I? There. Let's put that here as well. And let's now put in the code. And I guess we can simply remove that, and we can remove that. And then let's see. So first of all, we need our in which color, in which numeric space actually? Yeah, I guess. Okay, so R is an F64 equals, or let's do equals 0 F64. So RGB. Yeah, let's do that. And then we have this shortcut again, if S equals, so if that's actually then, yeah, let's call that V. If V.S equals 0, then we want to say that they are all, and then is there something like, okay, so it's not let, it's if. So if this one is there, then we are saying that R is VS, G is equals VS, and B equals VS. Yeah, and then we are golden, I guess, and otherwise. So this can go, there we are. So then we have something like, I have no idea what this actually is here, but I don't really care at the moment. I guess I need to invest some more time to research how this conversion actually is happening, because it sounds, or it reads kind of fun and interesting. So never done that. Okay, so let's do Q equals if L is less than 0.5, then we want L times 1 plus S, yeah, else we want S minus L times S. Okay. Not really sure why and what, but we can do that. So let P equal 2 times L to 2 times L minus Q. Okay. We can do that as well. And then we are actually doing all that. Okay, so we are doing Q to RGB P dot Q dot H plus 1/3. Interesting. Interesting. So F64. Yeah, so and this would then be R. Okay. And let's do that then for G and B as well. And this is without that. And this is with minus this value. Okay, so, and then in the end, we are simply, yeah, we need to take that there into account in a second, but in the end, we need to return, or we don't need to return, actually, we are just creating this one then as a color, I guess. So this one returns a self, so it returns color from RGB, and this will be R times 2550, and we are going to round that and then say it's a U8. And I guess we are doing that for all of those. So R, G, B, and this was one too many, so something like that. And now let's see. Now let's take this one out of here, I guess. And we have still from, there is something broken with the brackets. Let's see. So there, this needs to be somewhere. Let's put it to here for now, and let's comment it out. Let's clean up the brackets quickly so that I can see what is happening here. This one must be there. Yes. So actually I would have assumed, why didn't I just comment this one out? So okay, so it can't find you to RGB. Yeah, I see that. So let me put this one in here now. Let's do that. And let's simply implement this as an inline function. So as a function within a function, because you can do that in Rust. Q to RGB, and it takes obviously a P, which is an F64, a Q, which is an F64, and a T, which is an F64. And what does it return? It returns an F64. And there is an F missing, something like that. So, okay, let's go. So I guess we can more or less take that directly and try to convert it. So what we actually want is something like this, and then this, and this, and then this, and this would need 0 there, and we need that, and we need something like F64, and then maybe do it like this here as well, because kind of I find it better to read. Yeah, it's I'm going back and forth between the different kinds of writing this. So times 6 F64, and this here is an F64 and an F64, and actually this braces we do not need, but those we need. Come on. This can go, this cannot. And then we do that, and we do F64, and we do F64, and we do that, and we remove the brace there, and we do that here as well, and here as well, and here as well. And then where's this? I guess we need to remove that, and then we can format it and it looks a little better or worse, I don't know. And then, yeah, we cannot do that because it's not mutable. Yeah, I get that. So let's simply do something like let mut t equals t. Yeah. Okay. So, what's now broken here? A lot of stuff. Okay, I see. Why is it that, what is actually the problem here? A local variable with similar name exists. BP, wait, what? Wait, did I do something wrong there? Oh, this must actually be VL. So yeah. So maybe I want to kind of take them. Yeah, I guess I do want to do that. I guess I want to do something like v.h and let s v.s and let l v.l. So simply we are extracting them from there and wait. What's the problem here? So L expected because of, okay, I see. Yeah. That's fine. Oh, yeah. There is a semicolon which doesn't belong there. So and what's the problem here actually? Actually, what we want to do here is do that. But that cannot happen because they are not mutable. So let's make them mutable. And now, is the compiler now happy? It seems that it's mostly happy. Let's see. So yeah, we are not returning that. Yeah, we should return that. The trait-bound HSL color into is not certified. Required for HSL color to implement into color. Yeah, maybe we need to implement this on HSL color then. And take an HSL color, really own it, kind of, maybe. Yeah, then this works. Okay, so yeah, send new. Okay, I see. What's the problem here? I guess we introduced the random thingy there, didn't we? So I guess we can just do something like we called it E, I guess, erand. Can we just put that in there? And can we do something like give it a mutable reference to it? Okay, doesn't work. Rand of engine state is private. Yeah, that's of course an oversight. So struct engine state. This needs to be public, of course. Otherwise, it doesn't really make sense. So those are all warnings only. We can take a look at them later. So let's see if this compiles and works actually. So I'm okay. Okay, this color looks absolutely identical to me. There is no... Okay, let's check our code again. There is no differentiation within the color, and I don't really understand why. So, did we do something wrong in the struct send? Oh, it's the wrong file, yeah. Struct send. So let's see. We are actually taking... Yeah, we are not using our color here. We are, nice thing, we are calculating our color variation and then we are not using it to construct our object. Yeah, perfectly done. So let's see. Oh, okay, there is definitely something wrong with our with our hue and things calculation, because this is not how it should look, but it looks kind of, I kind of like that. Okay, and we are only varying the color now for each of our big circles we are rendering, not for our for the full, for each of those pixels. I guess we need to do that. But as you can see, it looks a lot more lively now, and it looks kind of a lot more like sand here, even though the calculation is obviously broken. So let's see if we can fix that. First of all, I want to fix something else before I forget. So I want to, where is that? Update. So no, when we are actually doing that cursory stuff, cursor position there. So yeah, we are giving this one a send part. So maybe we need to move this function into the grid to create this this send. Maybe the send needs to be created in the. Okay, this is a little bit more effectoring than I thought. Okay, then let's take a look at how, if we can somewhat fix the problem with the color variation there. So let's see. So what we are doing here is calling send color variation. So let's first of all, let's see what those values are. Because maybe they are not between 0 and 1. And that would be a problem for us, of course. So let's see. ds equals ds, dl equals dl. So I guess we can take a look at those. Yes, okay, but they look reasonable. They are all within our given limits, aren't they? Okay, the question is another one. The question is, wait. What? Our HSL colors, how are those defined? Let me do something like H equals L equals S equals S and L equals, come on, L. And then I guess I need something like H is HSLH and S is HSLS and L is HSLL. Yeah, maybe I should have just given the HSL color the debug trait. Might have been faster, but who knows. Okay, so, okay. Those are all defined HSL. Yeah, they are between 0 and 1. So the value I'm putting there on them is a lot too big. So I guess I need a lot smaller range here then. So let's do something like 0.5 seems even then too big. What we will see. So 0.25, 0.25. So let's see now. Okay, this is still kind of weird, I guess. But it looks a little bit smoother. But what I don't understand actually there is there must be something wrong with our hue RGB calculation, because what I do not understand is how a completely different hue can be created here. That doesn't make sense at all. So I'm taking the original hue and I'm changing the saturation and the lightness. So let's maybe for now only change the lightness and let's see what that does to our color, because I'm quite sure that, yeah, by only changing the lightness, it can't happen that the hue of the color shifts completely. But yeah, maybe I will investigate this off screen, because there is most likely something broken with the conversion routines. Or yeah, let's take a look at them. Okay, first of all, I guess we could check. Which of these directions is broken? So where is our Where is that? Okay, so let's see. We have somewhere where we call as HSL. No, we have an implementation here where we do that. Okay, I see. So let's first of all we can make this a little bit more rusty, but okay, let's see. Let's maybe yeah, let's maybe print line, yeah, let's print line as HSL H, there we go again, HS SL. So that would be interesting actually, so let's see. Okay. So this is actually already enough. So, oh, I should remove the other debug output. Where was that? I guess it was here somewhere. Yeah, let's comment that out for now. We might need it again. So just to make it a little bit more readable what we have in our console. Though, yeah, that should be already enough. So, it's telling me that I actually find that a little bit disturbing. Why is it such a low value? Usually I know it that HSL is defined from, so that the H value is defined from 0 to 360. So that actually seems wrong. The hue seems wrong. So if I do something like, is there something like HSL? We had this one open before because even we didn't want it. So let's see. Can we actually, yeah, I want to swap that because I want to do something like 0. What is it? 0.16, and then there is something like 1 here. So this would be 100%, and this will be 50%. Yeah, so this actually is red. Okay, so both directions don't work. So what would actually be a yellowish color? So no, we are already over that point. So it would be somewhere. So let's maybe calculate that here, 255. So what would it be? 60. Okay, so it seems that our saturation and our lightness calculation is okay, because that is 1 and so 100% and 50%, that is okay. So the question is, what the hell happened to the hue? Why is the hue broken? So the way calculating, I mean, could it be that this is actually in the range, that this is in the range as well? So what is if I do something like, what is it? 0.166 times 360? Wait, I do not want to. Okay, I see. So we are getting all the results in the range from 0 to 1. But is the color conversion code doing the opposite? Assuming that. That is the question here, I guess. But that is a really strange way of representing those values. So I don't really like that. I really don't like that. So maybe we should change that. But first of all, let's figure out, because hue is usually done in degrees. So where is our conversion code then? So as HSL, yeah. Let's take a look at the Stack Overflow article here again. So let's see. JavaScript solution, which attributes, defunct, and so on. Thanks to the code is reposted below, updated for post ES5 conventions. HSL to RGB. So conversion HSL to RGB, conversion formula adapted from, okay, there would have been a Wikipedia article, okay. Assumes HSL are contained in the set 0 to 1 and returns RGB in the set 0 to 255. Okay, that's actually the HSL to RGB that we implemented here takes the output values from the in the same format, even though I think it's quite strange to use that format, but okay, I can live with that. So RGB to HSL converts an RGB color value to HSL conversion formula adapted from, and so on, assumes RGB to be contained in the set 0 to 255 and HSL in the set 0 to 1. Okay, so it's actually doing exactly that. So yeah, so let's see. So that is actually what we are doing here. We are actually then preparing them by dividing them by 255 to move the RGB values into this other color space. Then we have this Vmax thingy here. So Rmax, Gmax, B. So it's the maximum of R and B and the maximum of that with, yeah, okay. So it's the maximum of those and the minimum min, we used min there, okay. So then we have HSL contain Vmax plus Vmin by 2. I mean, that's more or less the only thing that I changed, didn't I? Maybe I made a mistake there, but let's see. So we are actually initializing those values here, and then we are checking if it's an achromatic thingy there. So if Vmax and Vmin is the same, then we simply create this value, but we are not going into that. Then we are actually calculating Vmax minus Vmin to get the distance. Okay, I see. Then we are checking this is if L is bigger than 0.5, then we are doing D divided by 2 minus Vmax minus Vmin, yes. Otherwise, we are doing D divided by Vmax plus Vmin. Yes, we are doing that. That's the calculation of the saturation. Then we are actually calculating the hue. So hue is what did I do? Okay, no idea what happened there with the browser. Now it's back again. Okay, so where were we? We had the distance, we were at the hue stage. So now we are calculating the hue. So we are initializing it with this Vmax plus Vmin. That's the same thing we had here before. Okay, I get that. Then we are, then we are checking if Vmax is equal to R, then our hue is G minus B divided by D plus 6 or plus 0. So, but actually the division binds has more priority than the plus, so it should be absolutely fine for us to split this into 2 operations. Yes. I mean, I guess I could, but no, that should definitely make no difference. So G minus B divided by D. Yes. And then if it's smaller, then it is 6. Otherwise, it is 0. I see. So then Vmax G is actually B minus R divided by D plus 2. Yes. If it's B, it's R minus G divided by D plus 4. Okay. And then we are always dividing this thing by 6, and then, yeah, but, okay, I'm an idiot. We just realized that this conversion works because this is 60, but in a range from 0 to 1, so I wouldn't even have to check that. The other implementation must have a problem there, so that wasn't, yeah, Jacob, that was not very smart. Okay, let's see, there must be a problem then here. So we have got, no, not that one, RGB. So we are initializing those RGB values. I guess we don't even need to initialize them, do we? So I guess we can remove those. And then variable does not need to be mutable. Variable does not need to be mutable. Wait, are we setting them only once? Yeah, maybe. Might be. No. Oh. Yes, we are only initializing them once, either to S or either to this calculation here. Okay, makes sense. That is something, by the way, that I learned you can do in Rust. It's quite interesting. You can actually, or you don't need to define a variable as mutable if you are not initially setting it, but only setting it once later on. The only condition is that you are definitely setting it in every branch of the execution. Otherwise, the system will moan about that and tell you that the variable is not initialized and possibly returned uninitialized and stuff like that. But if you are doing it only once and not really mutating it after first setting it, this actually works. So that's nice. Okay, so let's see. We are initializing those and then we are checking. We are checking if we could, by the way, now do that because we set that. So if it's 0, then we are simply setting wait. Then we are setting all of those, but none of our values is 0, but there was already an error. Yeah, okay. So there might be more. Okay, let's see. So if Q is set, if L is less than 0.5, then it's L times 1 plus S. Okay. Otherwise it's L plus S minus L times S. Wait, there is something missing. L plus S minus L times S. So I was missing an L there. Maybe that was already our problem. So if L is less than 0.5, is this one? No, it's actually not. We actually ran into this arm, and maybe that's already the problem. But let's quickly check the rest as well. So P is 2 times L minus Q. Yes. Okay. R is then Q to RGB PQH 1 divided by 3. 1 divided by 3. Yes. The second one is PQH. Yes. PQH minus 1 divided by 3. Okay, those are okay. Let's quickly check this one here as well. So if t is less than 0, then add 1. Okay, yeah. If it's bigger than 0, then subtract 1. Okay, I get that. If it's less than 1/6, then return p plus q minus p times 6 times t. Okay. If it's less than 1/2, return q. Yes. If it's less than 2/3, return p plus q minus p d. Yes. P q p. Yes. Okay. Times 2/3 minus t times 6. Okay. This seems to be okay. What is it complaining here? Convert the identifier to snake. Yeah, that's perfectly reasonable. Let's quickly do that, but this can't be the error. Okay, maybe it was already the error that we found where this L was missing. Oh, this looks actually a lot better. Okay, I guess the amount that we are manipulating the lightness is still too much, but it looks a lot better and a lot more than. Let's maybe quickly. Okay, let's do that away and let's go here and let's something like sand color. I guess we need another nice sand color. Yeah, maybe something like that, but more. Maybe more sand tuney here, something like, come on, sand colors, HTML codes, sand. That's not sand, that's, yeah, maybe it is sand. I have no idea, but I don't like that. There must be some other, yeah, okay, then let's take that one. There is an RGB variant of it. So let's copy that one. Okay, and let's do that for a starting point. Where are we here in main? We need to, don't we have something like sand color? No, sand color variations. That's where we create that. And okay, so yeah, let's maybe do something like sand color let equals color from, come on, from RGB, and then We are simply putting those in there. And then we can do something like sand color here. Okay. And now we need our sand color variation to be a little bit less aggressive. So maybe we do something like let range equal 0.1 maybe, and we use range here. Range, and then we can use range here as well. Range. And then I guess I want to use it for the saturation as well again. So plus ds. And I guess we can remove that. And then let's see. Let's see how this looks. Actually, this looks a lot more like sand. Maybe I was wrong about the color. It would, of course, even more look like sand if we created those color swatches based on every pixel, or randomized on every pixel that we making fall here. But as this video is already a lot longer than I expected it to be, I guess I will stop here and do that either off screen or with you together in another one. But this looks already very nice. I had hoped to introduce more than one color in this video, but as I said, it's getting a lot longer. It's already a lot longer than I would have liked for it. But I really like this. I really like this effect. It's really nice how a little bit of color differentiation makes things look so much more organic. And with introducing more randomness, I guess in the next sessions or at some time, we can make it even nicer. So yeah, I hope you had fun and enjoyed watching this one, even though there was some bug hunting in between. But I definitely had fun doing that, and I hope you enjoyed it as well. So please, if you liked, hit the thumbs up, comment the video, subscribe, hit the bell. You know what you have to do on YouTube to make the algorithm rank this thing a little bit higher. So thanks again for that, and see you in the next one. Bye!